in sequences and series, now busy with the sigma notation. What does that sigma mean?
Sum
Sum of. Accumulation, adding together. So if I say determine that, what is the question? Determine
the sum
the
of.
sum of. There's a little bit of a problem with this one. Shane, and Ram just gave it to you. Because it says here that the, what is this called? The general term. The general term is 6. So what does the series look like? 6 plus 6 plus 6 plus 6. How many terms are there? Yes, I heard the correct one. Exactly. 12. Remember, guys, from yesterday, you are always going to say, how many terms are there? 11 minus 0 plus 1. It's because of that adding error in our brains that we say from 4 to 8, the first example, everybody thought it was 4, but it's not. From 4 to 8, 4, 5, 6, 7, 8 is truly 5. So all the time, it's never going to change. If I say from 0 to 11, it's going to be 11 minus 0 plus 1. So there are 12 terms. That's the first thing. Somewhere in your sum, you're going to get a mark for knowing that it's 12 and not 11. And then to do the sum, okay, do we need to write down the sequence? Because ma'am said to you always write down the sequence.
Yes.
Let's do it. Well, actually series, right? 6. And how many of them? 12 of them. So get me the sum of. Now you can go and say, this is arithmetic and the D is 0. But guys, it's just the sum of 12 terms is
12.
which is
72.
boom, finished. So how much would this have been for marks? 2. So it's basically just for knowing that it's 6 plus 6 plus 6. And then there are 12 terms, and so you say 6 times 12 is 72. So the guy who said 6 times 11 got no marks. He's going to got 1 out of the 2. Because the error is this common error that kids think it's 11 and not 12. So you wouldn't get no marks. If the sum was just worth 1 mark, then you didn't get the mark. Okay. So again, if ma'am says, now this time I don't say determine, I say evaluate, because they like doing that as well. Or calculate, or anything in the sort that says do the sum. What is the sum? Get the sum of. This is my general term. This tells me how many terms there are. Tell me again how many terms there are. 8 minus 1 plus 1, there are 8. If it's 1 to 8, everybody knows it's 8. No problem. Okay, so there are 8 terms. But the first thing you do is you write down the series. I cannot stress this enough. Kids mess this sigma notation up for some reason. But just if you listen to me and always follow the rules and always first write down the series, you will not make that mistake. First, the series. So first of all, I'm going to substitute the n with 1. If I had an n to substitute, I would have first substituted with 0. Could that n there be minus 1? Yes. It's not the term number. Okay? So that could even have been minus 1 to 11. Then there would have been 13 terms. Are you with me? That n there isn't the term number. Whatever the first one is, that's term number 1. So if it was sum of n from minus 5 to 17, it doesn't mean I've got an n that's negative now. It is confusing because we tend to think n is the position number, but it's not. For whatever, for n squared plus, I don't know what the general term is. For the first term, your n is substituted with negative 5, then with negative 4, then with negative 3. Are you getting this? All right. So first of all, the series starts off with n being equal to 1. Then this is in 3 to the power negative 1, which gives me a third. Am I right?
Yes.
Then if it's a 2, there's a 0 there. So the answer is 1. Then if it's a 3, and if it's a 4, seeing the pattern. We're seeing that this is not arithmetic, not quadratic, it's geometric. So that means I need to see the A and the R. Do you see the pattern going here? A being a third, R being 3. 1 divided by a third, it is 3. You can better see it if you see 3 divided by 1, it's 3. Or 9 divided by 3, it's 3. All the time, you've got that thing in the back of your head that you're all the time doing. Term 2 divided by term 1, term 3 divided by term 2. Although I don't always write it, it's there. And sometimes I'm going to need it, so make sure that you do write it in those cases. So what was the question? 5? The sum of. So I need the formula. Which one? Ma'am's favorite. Both of them work out the same. With R being 3, and this is in actual fact the correct one to have used because R is bigger than 1 or less than negative 1. So this is the right one, but even if you chose the other one, it will work out the same. Sum of how many terms did we say? 8 of them, with A being a third, R being 3 to the power of 8 minus 1. Don't get confused with all those other formulas with the n minus 1. This is not n minus 1. It's 3 to the n, then minus 1. And then 3 minus 1, and an answer please on the calculator.
3,280 over 3. 80 over 3.
Okay, do we change that into an improper fraction or a decimal? Please don't, just leave it. Why is it a fraction answer though? From here, it's always going to be a whole number. So if it would started there couldn't have been fractions in the sum of. But that third is here. That's the reason why it's something and a third. Are you with me? Just for seeing the practical of it. Just let's do another example where I ask that you will prove that this equals this. What type of a sum is this? Left hand side, right hand side. So I should prove it. Where will I start? Not times out and bring the stuff across. It's not an equation. It's got to be a left hand side, right hand side. Will I try and manipulate the right hand side? Well, all you can do is time it out. And then you're not getting here yet. Definitely, this is the side that's got some work. What work? I must go and work out the sum of that general term, where that k, do you see it in terms of k? K goes from 1 to, oh my word, p squared, getting more difficult. Alright, so first thing first, you always write down the series. So the series starts off with k being 1, so that's 2 times 1 plus 1 give me 3. If it's 2, it's going to be 5. If it's 3, it's going to be 7. I've got the pattern right. But now, somehow, somewhere, that p squared is going to come into play because that's my answer there on the other side. So, which one is going to have something to do with the p squared? The last term. Are you with me here? How many terms in this sequence?
P squared.
P squared. Because it's still p squared minus 1 plus 1. So there's a number of terms. It's still going to be p squared, which is strange, but it's okay, it's higher level. So if I go on and on and on, the last term will be when I substitute p squared into k. So what's the last term?
2p squared.
2p squared plus
squared.
1. Are you with me? 2p squared plus 1.
What?
Substitute the k with p squared. Done. Now, I've got to prove that. Now remember, that's not the answer. You can't work with it. You've got to develop it and hopefully it does come to p squared bracket p squared plus 2. So then to do this actual sum of, how are we going to do that? We need to know still that A is and R D, right, is 2. And then we're going to have to work with the sum of, because that's what this is all about, Sn. And I can work now with the arithmetic sequences and series, so that the formula is which one? The one with the last term. Because that's where the p squared comes into play. So you were forced to use the last term. You could go for the D1, but then you don't know what to do with the p. Then there's going to be no p over here, proving that it's equal to the right-hand side. And with me, how they forced you to work with the last one. So it's not level 1. So then to find the answer, tell me please what is n? Yes, the number of terms is p squared. Just looks so weird. And then in the n's place must be a p squared. Happy on that? And a's place must be a 3. And l
2p squared
plus 1. And then I'm hoping with all of my heart that this answer
is equal to the
will be equal to the right hand
side.
side. Will it be? Let's check. So we've got p squared over 2, and this is 4 plus 2p squared if I simplify. And then when I divide by 2, or times in by 2, what am I going to do to get to that one? This 2 has to disappear. Let's take it to the other side.
Yeah.
Because this is not an equation. This is not equal to 0. That I can do stuff. So how is that 2 gonna go away? Because I'm letting myself be led by the sum. P squared has to be there. All sorts of things you can do. I don't know if that's going to work. But how do I get this half away here and in there? Apply it. It means that this thing has to be divided by 2. How? Why would I do that? Because I'm being led by what they want. I want that half or that 2 away. It is divided by 2, so I've got to go and divide both of those by 2, giving me 2 plus p squared and the p squared there. Maybe you guessed. I don't know how that's going to happen, but I'm going to write it down, and you would have been correct. They would have given you the mark. So if all else fails, try. Did I finish the sum actually? I should be saying left-hand side is equal to the right-hand side. I want you to please try for me. No. I'm still going to carry on a little bit. I also want to do sum to infinity with you. And sum to infinity is where I'm going to get to the reason why I use certain Sn formulas in geometric sequences, series. So for the Sn formula, there's a new formula. What does that mean? Sum to infinity. Oh goodness. Okay, let me do a sum quickly, and you're going to see it's quick, and nice, easy marks, always 2 or 3 marks. It's going to be, and I'm going to tell you now what the theory behind it is. If it's something like are you seeing my pattern? What is my pattern? Okay, now if I am dividing by 3, what is R? 1 over 3. Please don't forget. You are right to say you divide by 3, but what is R? A third. Because that's divided by 3. Always check. Second divide by this first. Third divide by the second. And make sure that you got the right one. Because the formula is easy peasy. It's sum to infinity is equal to a over 1 minus r. That's it. It's on your formula sheet. It's on your formula sheet. So without explaining more, I'm going to explain the detail now to you. You're going to get this marks. If you know the formula, you apply it. Because you're going to have A is 9 and R is. And please give me an answer on your calculator. Please help me, am I right? Okay. Which means if I really want to go write it down 13 and a half, I'm saying that if I go on forever and keep on timing with a third, 1 over 27 is getting less. 1 over 81 is getting less. 1 over 300 and something is getting lesser and lesser and lesser. It's getting so lesser that it's going to go to infinitely small. So small that it actually tends to be nothing. That's why I can use sum to infinity. Now think about it. Already here I've got 12, 14, right? But then I'm adding fractions and lesser fractions and lesser fractions. So I'm not even going to get to a whole one with all these infinity little bits coming in there. So this is already 12, 13. And then it tends to be equal to a half all of the rest of it. That's sum to infinity.